Do you think there is life on Venus? As you know, nowadays we generally look for traces of life on Mars, but in the 1960s, the main planet we expected to find life on was not Mars, but Venus, because Venus, the planet most similar to Earth in the solar system. So much so that we call it the Earth's twin. It is only 20% smaller than Earth. In terms of proximity to the Sun, Venus is second and Earth is third. Both are rocky planets, both have significant atmospheres, and both are very likely. Venus once had oceans on its surface, like ours. But Venus's similarity to Earth. Unfortunately, it ends here. If we took you, who live happily on the surface of the Earth, and put you on the surface of Venus, it would be the most terrifying, most awful experience you could ever have in your life. Atmosphere of Venus, shrouded in suffocating, thick, yellowish clouds of sulfuric acid. Common air is mainly carbon dioxide. It is filled with gases that are extremely toxic to life as we know it. Despite this, it rains on Venus too, but with a difference. These are not romantic rains like here. Because what's raining down isn't liquid water, but sulfuric acid. This acid, which can be as strong as acid, corrodes everything it touches. Fortunately, these rains evaporate and return to the atmosphere before reaching the surface. But still, what a terrible environment this is. I think you understand. Also, the pressure on the surface is so high that until you take a breath of that stifling air, you would be crushed and shrunken like a soda can that has been run over by a bulldozer. Think about it this way, the pressure on the surface of Venus is around 90 atmospheres. This is the largest ocean in the world. Almost equivalent to the pressure you would experience if you dived 1 kilometer below sea level. I don't know which one is worse though. Is this a crushing from pressure? Or is it that your skin will scorch and burn? Because the temperatures on the surface of Venus are around 470 degrees Celsius. In other words, it is high enough to melt lead, and the heat that causes this temperature, he can't escape anywhere, because Venus's stifling atmosphere that I mentioned traps the heat on the surface like a deadly blanket over the planet. You will understand, Venus, which looks so beautiful from the outside, is actually a hell. But Venus wasn't always like this. Venus, which was formed about 4.5 billion years ago from the same solar nebula, that is, the same cloud of gas and dust as Earth, was formed billions of years ago due to its proximity and similarity to our planet. Had conditions comparable to those of the world. According to the analysis, Venus's surface has been covered with ice for an absurd period of time, perhaps 2 billion years. Oceans existed, which was more than enough time for bacterial life and even more complex life to evolve. We think that the valleys and ridges we see on the surface today were shaped by icy waters and potentially even by tectonic activity such as earthquakes and volcanoes in the past. These are indispensable conditions for life. But whatever happened on Venus, things went terribly wrong at one point. Perhaps it lost its magnetic field during a powerful solar storm due to its proximity to the Sun, or perhaps Jupiter pushed it out of its old orbit. We don't know, but for some reason, due to its proximity to the Sun, it began to be extra affected by solar radiation, which it already receives much more than Earth. This radiation rapidly vaporized those oceans on the surface. Since water vapor is a greenhouse gas like methane and carbon dioxide, an abnormal amount of heat began to accumulate on the surface of the planet, and the infernal temperatures we see today began to occur. These temperatures vaporized the water on the surface even faster. This water vapor decomposed into hydrogen and oxygen as it was pounded by the blazing sun. The lighter hydrogen escaped from Venus's gravity and was blown into space. The remaining oxygen interacted with gases such as carbon dioxide and sulfur dioxide emitted by Venus's active volcanoes at the time, forming the sulfuric acid rain I mentioned above. Since this acid is highly reflective, it reflected the sun's rays back, stopping the temperature increase and allowing a thermal balance to be established on Venus. Alas, that balance was fixed at a point so terrible that life as we know it could not survive. Even if life had evolved at one point on Venus, it had completely disappeared by this point. As you can see, if you want to see the real destruction that greenhouse gases, which are increasing on Earth and unfortunately turning our seasons upside down, can cause, look not too far away, but Venus. Venus shows the potential future of the Earth. By the way, we can know what Venus looks like so clearly because we have managed to land vehicles on the surface of Venus over and over again. To date, 46 separate missions have aimed to land on the surface of Venus, and 10 or 15 of them have been successful, depending on your criteria for success. I say this because we didn't know before what a terrible environment Venus was. That's why the probes sent at first broke up before they could even pass the atmosphere. Despite this, they managed to send us unique data, especially the famous Venera mission sent by the Soviet Union in the 1960s. First collected data from the atmosphere, and then directly from the surface, where they managed to land without breaking up. Therefore, our information about Venus does not only come from indirect sources. We know what it looks like there. Just look at these photos. They were taken by missions that landed on the surface of Venus. In fact, Venus is such a hell that the electronic circuits of these vehicles are in that environment, but they could only survive for 127 minutes at most. Then they broke down, but that was enough time to receive sound and images from the surface. Listen. So if you consider the conditions on Venus, it's not that surprising that attention would turn to Mars at some point. Although Mars isn't exactly a bed of roses either. I explained these in a video I made earlier about oxygen production with artificial intelligence on Mars. I recommend you watch that one too. Still, scientists decided that it was impossible for any life form to exist on Venus and chose to focus entirely on Mars. But here it is. Visionaries like Carl Sagan didn't think it was right to abandon Venus so easily. Mars research is important, of course, but according to Sagan, this research comes at the cost of abandoning Venus completely. It shouldn't have been done because the missions to Venus sent very critical data. Yes, the surface may have terrible conditions, but that surface, a considerable part of the atmospheric layers that are passed through until you descend 50 to 60 kilometers above the surface, are similar to living spaces on Earth. A temperature of 30 to 70 degrees Celsius, and pressure conditions similar to those on the Earth's surface. What about the remains of life once suspected to have existed on the surface of Venus, specifically microbial life? If humans continue to live in these layers of the atmosphere that are still suitable for life, then there is no place on Mars that holds such a possibility if you think about it that way. And that makes Venus a very good candidate. I know this sounds like a crazy idea at first, because we have a belief that solid surfaces, such as the Earth or the ocean floor, are necessary for life to exist. Bacteria and archaea that can survive in extreme conditions can also live, develop and reproduce in liquid particles suspended in the air. For example, I just said that sulfuric acid rain evaporates before reaching the surface and returns to the upper layers of the atmosphere. This type of cycle can ensure that microorganisms live continuously in the air. In addition, carbonyl sulfide, hydrogen sulfide, sulfur dioxide, and carbon dioxide are also found in large quantities here. Life may have evolved to survive using these gases. These thick cloud layers also protect them greatly from the sun's harmful ultraviolet rays. All of this points to a truly amazing possibility. But like every scientific possibility, this also needs to be proven. We can do this in two ways. The first is to send vehicles there directly, collect samples, bring them back to Earth and analyze them. With the increasing interest in space today, there are vehicles aimed at Venus. There is a little movement in the research, but we are still at the very beginning of the road. The Moon and Mars have garnered so much attention that Venus research has always been secondary or tertiary. Unfortunately, this will continue to be the case as long as the budgets of institutions like NASA continue to be limited. This is the bitter truth of humanity. This is it. The second method actually has the power to change this evil fate. If we can find traces of life on Venus using indirect methods, or at least if we detect strong signs of life on Venus, then the tremendous scientific possibility I just mentioned becomes even stronger. And managers of organizations like NASA, who are trying to allocate money to the most effective outcomes, choose to allocate more resources to Venus. To do this, we need not directly experience life itself, but we are trying to detect chemical and physical signs, that is, biosignatures, that we think may belong to it. But biosignatures also need to be specific enough to indicate life. For example, the reason we look for water in objects in space is that water is a basic necessity of life, as I explained in the video I shot of the cistern sunken into the ground. Naturally, finding water somewhere means there is a possibility of life there. But even though water is an important criterion for life, it does not carry a meaningful sense that guarantees that life is already there. In fact, water is much more abundant in space than you might think. Therefore, we need to find more distinctive biosignatures. One of them, a gas called phosphine, which was declared to be abundant on Venus in 2002. I made a video about this for you too. If we quickly recall, phosphine is actually produced by high-energy and abiotic processes such as volcanic activity, atmospheric events, and lightning. Some quantity can be produced. It also forms in the extremely hot and high-pressure inner layers of hydrogen-rich gas giants such as Jupiter and Saturn. Over time, they can fly into the upper layers of the atmosphere and we can detect them from a distance, such as Earth and Venus. On pedestrian planets, there are no environments that would allow this type of formation, but on Earth, phosphine, especially in oxygen-free environments. It is produced when living things break down organic materials. That's why the discovery that this gas now exists on Venus is incredibly exciting. Especially this gas is not on the surface, but right in the atmosphere, if you consider that it was detected in the critical layer between 1 and 80 kilometers. Of course, geological processes that we estimate occurred on Venus in the past may have produced phosphine. After all, Venus has become such a terrible planet. We know that volcanic activity plays a huge role. The problem is that phosphine is also an extremely unstable molecule. Therefore, it is not possible for the phosphine produced by volcanic activity that ended millions of years ago to have survived to this day. Especially phosphine, which is found in such abundance that it can be detected from a distance. Therefore, we need to find a source that produces it continuously, and we don't know of any abiotic sources on Venus that could do that. And this has the reverse, leaving only the possibility that life produced this phosphine. At least, that was the claim of the researchers who made the discovery. Other researchers weren't so sure. Because we still know very little about the geology and chemistry of Venus, and countless abiotic processes that we may not currently know about may be allowing this gas to be produced continuously. Furthermore, as I said, detecting phosphine is not done by taking gas samples from Venus. At least not yet. As it passes through Venus's atmosphere, some of it is absorbed, depending on the chemical components there, and some is reflected enough to reach us. Here, with telescopes on Earth, we can capture these unabsorbed photons and use a method called spectroscopy to determine which frequencies are absorbed, and since we already know which chemicals can cause light to change. In that way, we can understand what chemicals are in the planet's atmosphere. Of course, to do this, we use statistical and artificial intelligence methods. We derive mathematical models that we think will best explain the data we collect. Here, these spectral data and the analysis published in the journal Nature Astronomy in 2020. Other experts objected to the research findings on two grounds. First, there are gases other than phosphine. For example, sulfur dioxide, which is known to be abundant in the atmosphere of Venus, similar to those claimed to belong to phosphine. They claimed that similar signals could be produced. In other words, the signal was not strong enough. Their second objection is that the mathematical model they used to process this already weak data is not loose enough to produce any desired result. It was thought that it was a fig. For those of you with a math or data science background, the polynomial that the researchers used to describe the data was 13th degree. All of this is the discovery of phosphine on Venus itself, and casts doubt on any claim that it has any relevance to life. Although some very suspicious events took place there too. Maybe one day I'll tell you about them too. But in the end, it would be safe to say that our enthusiasm was thwarted. At this point, frustrated researchers could become whiny, insulting experts who questioned their data, engaging in worthless Twitter fights, and trying to discredit each other with verbal spats. But Dave Clements, who was part of the research team that discovered phosphine on Venus, and his team will convince the scientific community even more by choosing these methods that many people choose today. They rolled up their sleeves to look for more concrete evidence. And after 4 years of work, they collected 140 times more data than they used in that paper in 2020. They proved that phosphine was indeed there and that it was as abundant as they had initially thought, and they were also able to detect ammonia molecules that had not previously been definitively detected on Venus. Although it is not as strong a biochemical as phosphine, it is also a molecule that breaks down very easily, and because the thing that produces the most ammonia most of the time is life. Considering that it is found together with phosphine, it greatly strengthens the possibility of there being something organic in the marine atmosphere. But how? Exciting, isn't it? That's it. Is there life on Venus? We don't know. Of course, there may be other geological and chemical processes that could explain these findings. We don't know, but there is one thing you know very clearly. Venus, as Carl Sagan predicted, contains traces of past life and even actors who may exist there today. One of the strongest candidates we have for finding the creative life. It is not a planet that deserves to be pushed aside like that. For example, the researchers who discovered phosphine and ammonia have a 10 to 20% probability that their findings are a trace of life, and an 80 to 90% probability that they are a trace of life. And they say it's the result of a chemical process you don't yet understand. When it comes to extraterrestrial life, a 10 to 20% chance is an incredibly exciting possibility. Let alone 10%, even if it's a 1% or even a 1 in 1,000 chance, it was worth sending vehicles there immediately. What an amazing discovery. So hopefully Venus will once again be on the radar of space agencies. Perhaps a vehicle to be sent there. For example, the Da Vinci mission, which is expected to pass through the atmosphere and take samples in the late 2000s, or a new mission called Morning Star, after Venus is called the Morning Star. Not only will it find traces of life in the atmosphere of that beautiful planet, whose surface has terrible conditions, but it may also collect the first examples of extraterrestrial life. We won't know until we go. If you like this video, I recommend you watch this video that I shot in the heat of the moment on this subject in 2020. I go into a lot of detail that I can't go into here. See you in the next video. Goodbye.